Hello, everybody. I'm Fiveable. I'm super excited to get this stream started today. We are going to be looking at preparing for the AP Statistics exam that is coming up in just a few short weeks. I believe it's 2 weeks from Friday. 2 weeks from Friday at 1 o'clock my time, which is Central Time. So we are in full prepare mode right now. So I hope all of you are well, and thank you all for joining us. Today, our focus is going to be combining random variables. It's one of those topics that kind of gets lost. It's kind of in the middle of the course, and I feel like you're in such a go mode when you first touch on it that a lot of times it gets lost towards the end. So we're going to look at that today and kind of review some of the rules that I'm sure your teachers went over with you probably several months ago by now, and hopefully hone in on some of the topics that maybe you've forgotten and that you need some review on. Okay, so there's some really helpful rules that we're going to look at to help you prepare for this should it show up on your AP Stats exam. Feel free to follow us on all of the social media platforms: TikTok, Twitter, Instagram, and YouTube at Think Fiveable. Okay, I'm having a lot of fun on TikTok. I know I said that last week if you were here last week, but I'm having fun with it. I'm sure a lot of you are too. All right, so in this stream, we kind of have 5 main topics that we're going to look at with some examples kind of throughout that. So we're going to first look at transforming a random variable. So like scaling something up by either adding or multiplying by a scalar and what that does to a random variable. Then we're going to look at combining random variables, so taking 2 separate distributions and then adding those together, okay? Then we're also going to look at how to calculate the mean of a combination of random variables, the standard deviation of a combination of random variables, and then how we can use that new distribution to calculate probabilities. Okay, and I've kind of got a 2020 style free response sort of embedded into the last section there. Okay, so that should help you guys to kind of see what you should expect based off of a lot of other presenters that I've watched over the past few weeks, and also through some materials that AP College Board has put out. Okay, so let's hop on in. So first of all, what is a random variable? What exactly is that? A random variable is going to take on numerical values, and then it can be used to calculate the probability of certain things happening. So a random variable might be the number of minutes someone cooks their steak. All right. And then you have some people that might cook it for, 4 or 5 minutes. Some people 6, 7, 8, 10. And then there's people who like it really well done, 12 minutes. So that would be a random variable because there are some people who do it one way and some people who do it the other. And if you're looking at a distribution of everybody, it would be randomly selected. Now, granted, it might be more likely to occur at a certain number of minutes because that's the way the distribution works. But the random variable itself is the number of minutes someone cooks their steak at or whatever. Okay, so for instance, here's another one. We can look at the set of heights from an AP statistics class and find the probability of being at least 60 inches tall. Our random variable here would be height in inches. Now, one of the things that I noticed a lot throughout this year, through any resources that I got from the College Board aligning with their course and exam description, the CED that was new for this current exam that we're about to take, is there's a lot of emphasis on being able to define a random variable. I think that would be a great intro part A question for this year's layout, this year's exam layout. So we're going to kind of touch on that and what you would need to do if the prompt is to define the random variable. What would you do? Okay. For example, Mrs. Sample records the height in inches of all of her class. She gets the data set below. So these are all of her students in her class. Okay, so A, define the random variable being described here. Okay, this is, it's really easy, but it is necessary that we kind of clarify what we're talking about because we're going to say X. Okay. Yes, this would be discrete if you're measuring just in whole inches because you could be 71 and a half or 71 and 3/8, but it looks like she's just measuring whole numbers. But the way we're going to define the random variable is we're going to say x equals the height of the students in inches. Okay, so our random variable is actually the height of the student in inches. That is how we're going to define it. I always use X and Y, capital X, capital Y, when we start combining two of them in a minute. I think that it is just more clear. Most people use X and Y, so I think that's good. But notice that it has a quantity attached to it. If it is okay, so for instance, is this quantitative or categorical data that we're given here? Y'all can feel free to answer in the chat. All right, Katie says quantitative. Riley says quantitative. Yes, it is quantitative. Okay, because every person is assigned a number. Okay, now if I had records the favorite color of all of her class, that would be categorical because they would be falling into the red category, the blue category, the white category, the black category, whatever category for the color. Okay, but this one, there is a quantity attached to this particular variable. That's why, and I want to make sure that that quantity that we're measuring is clear in my definition of my random variable. Okay, just one of those little caveat things that they really want to see to get that full credit. So if you see define the random variable, this is what they're looking for. And probably later in the question, you're going to look at what's the probability of X being at least 70 or 71 or less than 62 or whatever it may be. Okay. But I can see here what X is representing. What's the probability of X being less than 70? You could exchange that and say, what's the probability of a height of a student in inches being less than 70? And then it reads pretty normal. Okay, so calculate the mean and standard deviation of X. Would anybody prefer to use good old-fashioned formulas to calculate at least the standard deviation here? Anybody? Mean isn't that hard, right? But standard deviation can be kind of cumbersome. So what I would prefer, and I think this is what I've sort of detailed for you, is using your calculator. Now, all of my students, and myself included, use a TI-84 plus CE. So that's the one that I used through this software. It is currently free for students taking any course, really, but you could easily get free software that does the graphing calculator stuff that you need. Now, AP has made it clear that you will not need a calculator for this year's exam. So I don't think that you're going to have to calculate the mean and standard deviation. But if you did, the calculator is free. You can download that. It works on Mac, Windows, or Chromebook. So the Chrome OS. So whichever one you need. That link is pretty easy to find. If you're interested in that, say something in the chat and I will be sure to track it down for you and we can get that for you. Okay, so I'm going to type my data into my L1. It's kind of hard to see. I'm just giving you a reminder of how to do it in the calculator. So I typed it into my L1 and then I went to first variable stats. So I went to stat, went over to calculate, and it's like one of the first options that pops up. And you are correct, Josie. The mean is 66.85. Okay, I rounded just to 66.8, which I guess technically would round up to 0.9 if I went to one decimal. AP's stats are really not that particular about rounding numbers, so I think you would be fine either way. And then our standard deviation is 4.54. So notice on the calculator output, I even had to kind of review a little bit just to be sure I was prepared for this because it's one of those tricky little subtopics in there. We have two standard deviations. We have 4.723 and 4.537. The one that we want is the 4.537 because that is the standard deviation of an entire population. And here we have the whole population. She has recorded the height in inches of all of her class. So we are just looking at that particular at this class, and we have all of the data points for that class. Okay, so therefore it is the population. We want the sigma of X, not the S of X. Okay, remember if it's a letter, it's for the sample. If so like X bar, here, you know, we didn't use mu. That can be kind of confusing as well. But there is no mu to choose from. There's only one mean on the whole list, so that makes it a little bit easier. And the standard deviation is sigma as opposed to S. So S and X bar go together, even though here we used X bar. That's kind of a tough topic there to touch on. But in this case, when you're calculating the standard deviation from a data set like this, you want the sigma of X from your calculator. Okay. All right. Any questions on those? Every calculator is different. So you might be working with a Casio or a TI Inspire, does it a little bit differently. I don't think that's going to be required on this year's test, but, you know, just kind of walking through what we had there. I think this could be given to you and you could do what we're going to do in the next step. So transforming random variables. So when we transform a random variable, so we're taking that X, those heights, and we took the mean and the standard deviation, and then we're going to change them in some way. All right. If I'm adding or subtracting a scalar, so let's say that Mrs. Sample decided that everybody was 5 inches taller than what they actually measured out to be. All right. Our mean, we would add 5 to. Okay. So we're actually going to add or subtract our scalar when we're changing our mean. Okay. Our standard deviation, however, is not changed. So if we're adding something to a distribution, we're going to change the mean. We're not going to change the standard deviation. And the reason why is really pretty simple. If you think about a normal curve, okay, and you add 5 to everybody, well, that normal curve is not changing shape. It's just going to shift over 5, okay, or backwards 5, depending on if you're adding or subtracting. So the shape doesn't change any. The spread doesn't really change any. It doesn't make it more spread out. It's the exact same shape, just moved over a little bit. So therefore, the standard deviation isn't changed. Okay, the minimum and maximum are still the same distance apart, and it doesn't affect it. Does not affect the standard deviation. So adding something to a random variable, the mean is changed. The standard deviation is not changed. All right. Now, if we are multiplying by a scalar, this one's a little bit different. The mean of the original variable is going to multiply. The standard deviation is going to multiply. So both of them change with multiplication. So that's a good rule there to sort of hone in on. If you're making a cheat sheet for this year's exam, that's maybe something I would want to include, just that little snapshot there. If you want to take a screenshot of that real quick, that would, that's fine with me. You can definitely do that. The slides are available afterwards through the Fiveable website as well. A scalar is just like a number. All right, just a number that we're scaling something by. So if we're scaling something by adding, like if your grades. So sometimes teachers scale grades by adding 5 to everyone's score. So that would be a scalar of adding 5. Sometimes teachers scale grades by multiplying by 1.2 or 1.5 or 1.8. That would be a multiplication scalar. So you would, multiply whatever the average originally was times whatever that multiplication scalar was. It's basically just a number that we're scaling something by. Does that make sense, Katie? Okay, good deal. All right, so back to our original example. It says, Mrs. Sample realized that her data was skewed because the height was measured while students were standing on a scale that they measured their weight. So they measured their weight and their height, but their height was a little bit off because they were standing on a scale when they marked their little spot on the wall. So the scale is 1.2 inches tall. So what is the new mean and standard deviation? So what do we need to do to all of our data if everyone was measured incorrectly here? How are we going to adjust all of their heights? Subtract 1.2. Good. So we're going to take, one way to do it is you could take every single person's height that we had, all 11 or 12 students, and subtract 1.2 from all of those, and then redo your first variable stats. Okay, that's a lot of work, and it's really not necessary. We also can just use these rules here that we have. So since we are subtracting, the mean is going to change. Okay, we are going to subtract 1.2. So then our new mean is 65.6, And then our standard deviation, since we're subtracting, is not going to change. So it's unchanged at 4.54. Okay. So everybody was 1.2 inches off. Therefore, our mean and our standard deviations, our mean is 1.2 off, but our standard deviation is the same. It's still going to be the same amount of spread out. It's just going to shift down a little bit. Okay. Any questions on transforming random variables before we move on to combining two separate variables? Any questions? Feel free to stop me, slow down, anything like that. Ask a question, pop something in the chat. I'll be glad to slow down a bit if necessary. All right. So combining random variables is a little bit different. So this is where we're taking two separate random variables, x and y, and we're putting them together in some way, usually adding or subtracting. Okay. So for instance, we could look at a class set of test scores on test 1, that would be variable x, and on test 2, which would be random variable y, and we can combine those together to look at how they performed overall on both tests. Okay, it's probably how someone's sort of average comes into play with a class if they only had 2 tests at that point. Okay, so the first thing is what happens to the mean? So when I'm combining two random variables, our mean of our combination can be found by doing the following. So t is my combined variable. I'm either going to add my two means or I'm going to subtract my two means, just depending on how on what the problem is requiring of you. You know, if you're adding up 2 test scores, you would add the two means, the mean of test 1, mean of test 2, add them up. That would be the mean of our new random variable. If we were subtracting 2 things, like I know there's a question on an AP Stats exam several years ago, that was the diameter of drink cups and then the diameter of lids. And the difference had to be within a certain amount so that the lid would fit on the cup. So in that case, we were taking the mean of the lid diameter and subtracting the mean of the cup itself. So that was one that called for subtracting the 2 variables. We're never going to multiply 2 variables, at least not in AP Stats, at least not in this course. Okay. Mean is definitely the easier of the 2 to calculate since you're really just adding or subtracting 2 numbers. Okay. And it makes sense. It's what you would expect to happen. So, you know, depending on how you're combining them, you add the 2 variables, you add the 2 means. You're subtracting the 2 variables, you subtract the 2 means. Remember keywords for subtraction like difference. That would be something you would see. You know, how much more than is one thing than the other, that sort of thing would kind of lead you to think subtracting. All right, now standard deviation is a little bit different. So let's look at that real quick. So when you're combining 2 random variables, our standard deviation of our combination can be found by doing the following. So we cannot add 2 standard deviations. We have to convert them all to variances by squaring them. We can add variances to get a new variance of a combination. So that's what we did. We took the standard deviation of x and we squared it. And we took the standard deviation of y and we squared it. We added those 2 things together and that gives us the variance of t. Now I can take the square root of that variance to land on my standard deviation. Okay, notice also I'm always adding. Part of that is because we have to square them. So if we were subtracting something and then we square it, it's going to become positive. Anything negative is going to square out to be positive. Okay. All right. So it's a little bit trickier to calculate, but what I've always called it is it's like the Pythagorean theorem. You take the standard deviations of our 2 smaller variables are essentially our legs of a right triangle. And we square those, we add them up, and then we take the square root, and it gives us our new standard deviation. Okay, so you always have to change your standard deviations of your original variables to variances, add those up to get your new variance, and then convert it back to standard deviation by taking the square root. Okay, that can be tricky. Also, you're always adding. You can subtract means, but if you're subtracting 2 variables and you want to find its new standard deviation, you're going to add their variances, never subtract them. Okay, so standard deviation is kind of the catch there. It's kind of weird. But once you combine them, you know, the probability part of it is really pretty simple. So it's also worth noting that when we combine two normally distributed random variables, our combined random variable is also normally distributed. So that's also really important there. If you have X is normally distributed test scores and Y is normally distributed test scores, and you want to add those two random variables together, that new combination variable that you have is also going to be normally distributed. So then you can calculate things using z-scores or using normal CDF, whichever way that you decide to go. Okay, and that's exactly what this says. So once we have our new mean and standard deviation, we can calculate probabilities just like we would using, you know, normal CDF or the z-score table, whichever route you decide to take. Okay, so let's look at an example. So a couple works for Lyft every weekend. They're trying to make some extra money for their family. Got to get that dough. Both of their amounts are normally distributed. Okay, so John's amount every week is normally distributed, and he makes an average of about $451.60 with a standard deviation of $5.75. Kari makes an average of $502.34 with a standard deviation of $14.67. Okay, so John and Kari, they both work for the same company, a little bit extra on the weekends to make some extra money. And those are your means and your standard deviations. All right, so A, define the random variable that is a combination of their total income. So this is one of those defining the random variable problems that I really could see that being a part A in either question 1 or question 2 this year. So what would you say the random variable here would be that is a combination of their total income? How would you word that? Throw that in the chat for us. We'll call it T. So what is T? T equals what? Okay, Katie, be a bit more specific on average amount of money. Okay, same thing, Riley. Be a little bit more specific. Is it the amount per weekend or the average amount? There we go. So the average amount of money of John and Kari. Okay. So Riley, you could say the amount of money per weekend of, you know, combined John and Kari. It just needs to be obvious that you're referring to the combination of the two. Okay. Be as specific as possible. Include context always. I'm sure your teachers preach that at you all the time at AP Stats, but that is what you're, you know, what we definitely want to get credit for that context. Okay. So I did T. So I said, let T equals X plus Y be the total income made from Lyft for the couple. So total income made for the whole couple. Okay. I think it would have been better to say what Katie had. So total income made from Lyft for John and Kari, where X is the total money made by John and Y is the total money made by Kari. Okay. I think that kind of clarifies a little bit more. I think it's always a good idea in that case to also say what X is and what Y is. I don't think it would be required, but, you know, I'm trying to give you like the perfect model responses and then kind of coach you through getting what you need to get the credit. Sometimes, most of the time, those student responses don't look like the perfect model responses the College Board posts. So, all right, B, find the mean and the standard deviation of T, which is our combination variable. So y'all take a minute and calculate the mean. Let's do mean first. What is the mean of T? Everybody's getting out their smartphone, their calculators. Wish I had candy I could like throw at y'all when you get one right. Like, oh, you got it. All right. Katie says 954.03. Josie says 953.94. Very close. Answers are very, very close. Anybody else have anything else to chime in? Any other amounts you've got? All right. I got 953.94. All right, so all we're doing with mean, I was trying to see, Katie, because you're really, really close. You're only 9 cents off. I wonder if you just typed in something wrong in your calculator or your phone. That's my guess. You just typed in instead of 0.6, 0.69, or something like that. So yeah, you're just adding up the two means. Okay, so we're just taking our John's average 451.60 and adding it with Kari's average 502.34, and they add up to be 953.94. Okay, and that would be that. All right, so standard deviation is a little bit different. So I'm going to create a poll. You guys to answer for standard deviation. It's all standard. Standard. There we go. All right. So the question is, can I just add the 575 and the 1467 to get our standard deviation? All right, we got a lot of answers for no, and Katie looks like a step ahead here. 3 votes for no. 4 votes for no. There's 24 people there. I think we can get 24 responses. Like I said, I'm throwing virtual candy at you right now, okay, for you participating. You want a butterscotch? Here you go. There's a butterscotch. You want a cinnamon drop? Here you go. Sour Patch Kids. That would probably get you participating. All right, so we got everybody saying no, and Katie has sort of given us the formula. It is the square root of variance 1 plus variance 2. Now, I don't know the variance for John and the variance for Kari, so how can I find the variance? What do I have to do with 575 to give me the variance? Somebody throw that in the chat. What do I do with the 575 to get John's variance? I would throw you a virtual Snickers bar for getting this answer. Come on, somebody. Come on. Okay. You have to square them. Okay. So I have to square John's standard deviation, which is 5.75. And I have to square Kari's 1467. And then I have to add those up. And that gives me 248.27. Now you might be thinking, oh, well, that's not the answer that we had in the chat. But let me tell you, this is not our standard deviation. This is our variance of our combination variable t. All right. Now to find the standard deviation, we have to take the square root of that 248.27, which gives us an answer that is really, really close to what Katie has. I think our differences are because I rounded my answers when I was doing this, when I was calculating it. So I did 575 squared, which is probably a number larger than probably a number larger than, whatever. And then 1467, I probably rounded my decimals. I'm not sure, Katie. It's probably rounding issues. So that's probably what it was. I was seeing if I had any more work there. I don't though. So maybe you rounded your answers when you added them and took the square root. Maybe I added mine. I don't really remember. Or maybe I didn't round mine down, but that's probably what it is. If you had that with work showing what you had, you would probably be A-okay in the eyes of College Board. Yes, I don't think you'll have points taken off, Katie. Okay, so I think you'll be just fine. As long as you have work that shows getting your answer, you should be fine. Okay. All right, so part C, same prompt. Interpret the standard deviation. All right, so that 15.75, is that right? Well, 15.76, or if you're using Katie's answer, 15.94. So what does that mean? What is the interpretation there? Very likely you're going to have a lot of interpretation problems. You always do, actually. But with this year being limited on the amount of calculating you can do, I think that you're going to have more interpretations. Okay. So remember what the standard deviation is. It is the average distance away from the middle, which is the average. So it's the average amount you're away from the average. Okay. So their total income differs from the average of 953 by about 1576. Okay. So every week, their total amount differs from $953.94 by an average of 1576. Okay, that is our distance away from the mean. Some weeks it's $15.76 more. Other weeks it's $15.76 less. Sometimes it's $31 and 26 times 2, 52. So sometimes it's 26.52 off. That's 2 standard deviations away from the mean. But on average, you take all the weeks and you add them up, the difference is on average about 1576. Okay, some of them, they're going to be right on their average, but that's kind of the difference. That's what standard deviation means. Now, I know a lot of people get that confused with the definition for a z-score. The z-score is how many standard deviations one person, or 1 week in this case, is away from the mean. So a positive z-score for 1 week would be how far above the mean they are. A negative z-score is how far below the mean they are. But standard deviation is never going to be negative. Standard deviation is measuring a magnitude. It's measuring an amount, so it can't be negative. Okay? Standard deviation is always positive, so you're never going to, it doesn't have a direction associated with it. It is on average, how far is it from the middle? What is the magnitude of the distance, okay, that it is from the middle? All the points, the distances from the middle, and you average all those distances together, voila, you get the standard deviation. That's a definition from like chapter 1 and 2 that does come up throughout that I would definitely look back and make sure you're familiar with before May 22nd. I'm sure it's popped up in the cram pass streams as well. My captions are great here. It said the Krampus streams. Anyways, all right. So D, find the probability that they make more than 1,000 in a weekend. Okay. What process would I use here to calculate this probability? Feel free to throw that in the chat. What process would I use? Is it a formula? Is it a Is it a what? Don't make me get my virtual candy out again. Come on, guys. So what we're going to do, so since both of the amounts follow a normal distribution that was given in the prompt, that therefore the distribution of t is also going to follow a normal distribution. So therefore, with the calculator, we can do our normal CDF. So normal CDF from 1,000 to however you want to represent infinite or infinity. I always say a bagillion. So normal CDF from 1,000 to a bagillion with a mean of 953.94 and a standard deviation of 1576 from our calculations on part B. And that is a 0.001% chance. All right. So in other words, it ain't happening for them. All right. They are not, with those numbers that we have from our data, they are not going to make $1,000. Okay. Seems like it would be kind of likely, right? 953, but our standard deviation in terms of dollars is pretty small for a normal distribution. So not going to happen. Now, make sure if you did this on the test to label your calculator speak. Lower limit, upper limit, mean, standard deviation. Full credit there. You have normal, you have your parameters, mean, standard deviation, you have your upper and lower limits. Those are the things they normally look for on a normal curve, which I recommend drawing that as well, just to be sure that you check those boxes, those three things they're generally looking for. But if you do this and label things, you're good. You've hit all the high points. Okay. All right. So E, it is their anniversary this weekend. Okay, John and Kari celebrating an anniversary. Woohoo! And Lyft has decided to give them a bonus by multiplying their total amount by 1.1. So in other words, they're giving them a 10% bonus. Like, hey, you've been working really hard this weekend since it's your anniversary. We're going to multiply it by 1.1. Find the mean and standard deviation of their bonus week. All right, so this, we're taking a random variable that we got from our combination, and we are transforming it by multiplying by 1.1. Is that going to change my mean? Yes or no? I'm going to create a poll. And you guys, answer over there. Yes. Okay, so I'm going to give you all about 20 or 30 seconds. Is this bonus going to change their mean? Yes or no? All right, got some votes for yes. All right, so we're going to let B be the amount of money that they make on their anniversary weekend. So we're changing it from T. Yes, you do multiply the mean. So we are going to multiply it by 1.1. So now our average is 1049.33. All right, what about standard deviation? Let's do another poll, because why not? All right, so is our standard deviation going to change by that scalar multiplication of 1.1? All right, we got to vote for yes. Anybody think any different? All right, yes, it does. So we're going to take that 1576 that we had from the previous parts, and we're going to multiply it by 1.1 as well. So now our standard deviation is 17.34. So multiplying by a scalar, you change both the mean and standard deviation. If we were adding, say if they gave them $50 bonus, just added, okay, our mean would change by adding 50, but our standard deviation would not. Standard deviation only changes with multiplying. Mean changes with adding or multiplying. Okay. All right, let's wrap things up here with the last part. So they decide to save all of their earnings for their anniversary week towards a vacation. The vacation is going to cost $1,000. What is the probability they will be able to pay for it in full? Okay. So there's our mean and our standard deviation. And we are going to calculate our normal CDF. It's the same problem that we had before. Okay, a normal curve scaled by 1.1, still going to be a normal curve. $1,000 to $1 billion was the probability of falling somewhere in there, with an average of, or a mean of 1049.33 and standard deviation of 1734. And that is 99.7% chance. Clearly, the mean is a good bit more than the amount you need for the vacation. So more than likely going to happen. So it looks like they are going on vacation. Whoop, whoop. Okay. So notice that one problem took two topics. It took combining random variable, and then it used that combined random variable to do a transforming problem. So you had that dual part there. Okay. So that is kind of what you can expect for this year's AP exam. Take multiple ideas, transform them all into one problem, and kind of see what happens. Okay. Any comments or questions? I didn't see any questions pop up on Crowdcast. If you have any questions, you can put them in the chat. I can go back to slides and we can chat for a minute, or we can, I can further explain something if we need to. Does anybody have any questions or comments? I'll give it 2 or 3 minutes and then we'll end it. Yes, there is another live stream tonight for the AP Stats Cram Pass. If you're a part of that, it starts at 9 Eastern, 8 Central Time. So Katie, if you are on Eastern Time, yes, 9 o'clock is the correct time. Same to you, Katie. All right, guys, everybody, y'all have a great week. I hope your studying is going well. Hope everything is going well for you other than studying. And we'll see you back here next week when we look at formula sheets.